Assalamualaikum and very good morning to Mr. Nurul Zaidi. Today, I will be presenting about a research paper on development of industrial robotic arm. First of all, my name is Muhammad Daniel bin Zainuddin. My matrix number is 01 BMS 21 F3009. I'm from BMS 4A. We go to the introduction. Nowadays, robots are increasingly being integrated into working tasks to replace humans, especially to perform the repetitive tasks. In general, robotics can be divided into two areas, industrial and service robotics. The International Federation of Robotics defines a service robot as a robot which operates semi or fully autonomously to perform services useful to the well-being of human and equipment, excluding manufacturing operation. So normally these robots are used in many fields of application, including office, military tasks, hospital operation, dangerous environment, and agriculture. Next, we move on to robotic arm definition. Robotic arm is a manipulator, usually programmable, with similar function to a human arm. Its limbs of such a manipulator are connected by joints allowing either rotational motion, such as in an articulated robot, or translational, linear displacement. The business end of the kinematic chain of the manipulator is called the end effectors, and it is analogous to the human hand. So here we know that the operation, standard of procedure for the robotic arm operation is same as a human hand. It can move, it can twist, it can spin, it can grab, it can hold something. So function of robotic arm is the same like human arm. Just there are more, the robotic arm are more further with the technologies and with their than human being arm. So here is a material of wind turbine. Sorry. So this is image of the block diagram for the robotic arm. Here is the flowchart for the robotic arm. Now we go to control state diagram of reconfiguration. The key to competitiveness into the global market is the ability to respond quickly to change while maintaining stable system operation and efficient use of available resources. In the manufacturing domain, there has been a considerable amount of interest recently in distributed intelligent control solutions to address this issue. So here is why today industrial manufacturing process, industrial manufacturing need to have robotic arm because they need to go fast. Like what I just read. Today global market is the ability to respond quickly to change. So they need to respond fast. They need to produce outcome with more faster to compete to other company or other manufacturing industrial. So here is the image of the control system of reconfiguration. Now, lastly, we move to conclusion. The objective of this project has been achieved, which was developing the hardware and software for an accelerometer control robotic arm. From observation that has been made, it clearly shows that its movement is precise, accurate, and is easy to control and user-friendly to use. The robotic arm has been developed successfully as the movement of the robotic can be controlled precisely. So that's all from me. Thank you. Assalamualaikum.
Good day, everyone. My name is Navaniswaran Anandan, and my matrix number is 01 BMS 21 F3011, and I'm from BMS 4A. And my topic for today is industrial robotics in factory automation, from the early stage to the Internet of Things. And before that, I would like to thank my lecturer, Mr. Nurul Zaidi bin Kasbul, giving me this opportunity. Okay, next. Okay, first of all, introduction. Robotics is a surprisingly old discipline, and robots have shaped industry and the various industrial revolution for many decades. This survey is relevant to the Technical Committee on Factory Automation, focusing on particular on the evolution of industrial robotics. And the aim is to reveal the close link with the industrial communication systems and to discuss the role of advanced communication infrastructure in fostering industrial robotics in the smart factories of the future. Next. Okay, now we are looking at the evolution of industrial robotics. First, we're going to look at the first generation. Okay, the term of robot, which means worker in chess, was coined by K. Capek in 1923. It's like showing the class fighting in a society with automated workers. Okay, next, Isaac Asimov first used the term robotics in science fiction books that inspired scientists and engineers to develop the early industrial robots. And robotics is applied to the new fields that were unthinkable some years ago, such the space. Okay. Industrial robots are everyday more light, tough, fast, and easy to reprogram with new features to understand their environment. And it's like also interact with it and with human in collaborative tasks. Okay, next. The next one is traditional applications domain. Basically, industrial robots have many applications, and the most representative can be described as follows. First, spot welding, spray painting, electronic testing, metrology, assembly, and finally machining. Okay, first, spot welding involves applying a welding tool to some object, such as a car body, at specified discrete locations. This requires the robot to move its hand to a sequence positions with sufficient accuracy to perform the task properly. Next is spray painting. It's like requires covering a surface with an even coat of paint. This is typically done by pre-specifying the trajectory along which the arm will move. The trajectory specifies both position and orientation of the nozzle as a function of time. Next is electronics testing. Electronic testing by robots is being widely used. One application is that of testing the continuity between pins, which involves primarily point-to-point operation. The next one is metrology. Metrology is now often performed using automated coordinate measuring machines, which are like essentially very slow and accurate robots. They are used to measure dimensions of mechanical parts, usually by a sequence of point-to-point motion. And the next one is assembly. Assembly is an application of increasing importance. Robotic assembly may be done in different ways, and like one typical method is to equip a simple robot with a special and effector of a particular task, such as inserting a component. Okay, finally, machining. Machining of mechanical parts is a growing application of robotics technology. Operations like grinding, deburring, drilling, milling, polishing, spindling, and sandling parts require the ability to follow surfaces and to maintain the forces required. Okay, next. Okay, now we are gonna look at the current trends. Robotics as a service, RaaS, is another important trend. This concept of offering services instead of the products used in providing the services is and has been a way to introduce untested products into the marketplace but many enterprising startups are finding economics of scale benefits the service provider. The use of unnamed aerial vehicles to capture sensor and camera data, and then developing software to analyze that data and translate it into actionable plans has crossed industry boundaries. Better and low-cost vision systems, particularly low-cost 3D visions, navigations, and mobility are enabling a variety of existing and startup companies. And finally, the number of employees likewise increased parallel to the growth of robotic automation. The operational stock of industrial robots showed a parallel increase averaging 3% per year, and also like the increasing demand then triggers more jobs. And next. Okay, now we are looking at the role of industrial communication. The original goal of industrial communication systems was to bridge the manifold gaps in automation systems and to allow for information exchange on the top of floor and beyond. By the time field bus systems appeared in the late 1980s and 1990s, robots were already advanced machines. The actual control of the robots was localized, and the coordination between robots was not necessary. In those days, robots were mostly part of integrated workstations that were connected via conveyor systems, but at least loosely coupled in a control sensor. With the introduction of real-time Ethernet (RTE) system, things did not change too much. Um, This is mostly because RTE was largely seen as a new generation of field bus system based on modern technologies. Okay, next slide. Now I'm gonna explain about the issues for the future of industrial robotics. Robotics will play a key role, which is like innovative technologies and solution traditionally associated with the service robotics sector are going to migrate to industrial smarter robots that will draw on a much broader range of technology, allowing higher levels of dexterity and flexibility. Next, smart robotics applications are being developed and tested every day, but often only through experimental setups built within laboratories, not fully coping with the real industrial requirements. And finally, the factory of the future scenario relies on the presence and cooperation of both manipulators and mobile agents, where sharing spaces with the human operators, like directly cooperating with the robots, and so on. Next. Okay. As a conclusion, industrial Internet of Things and other technologies have exploited distributed data sensing, gathering, and analysis for autonomous decision making, enable a level of automation never seen before in industry robotics. However, the gap between the academic most recent developments in robotics and the organizations and workings process of most of the current factories is still significant and should be cancelled or at least reduced to speed up the expected renewal of the manufacturing process. Hence, recent results of these activities make it possible access the role of advanced communication infrastructures for the most promising topics in the robotics area in the smart factories of the future. That's all from me. Thank you.
Okay, start. A very good morning to our beloved lecturer, Mr. Nurul Zaidi bin Kasbullah. My name is Tarumaraja Anarki Sivanesaselvan and my matrix number is 01BMS21 F3014. Today, I will be discussing about a case study on industrial robot in manufacturing industry. The title is Evaluation of the Automation of Material Handling with Mobile Robots. Next. Okay, first we will look into the introduction. Automated Guided Vehicle AGV first started to be used in 1950 for manufacturing. This technology began the trend of automation of material transportation. They have proved that to reliable and efficient technology equipment for more than 50 years. Changes to the pathway are simply too expensive and disruptive to be cost effective as they are typically installed in the floor. In response to the AGV's drawback, a more sophisticated solution to material handling was recently introduced to the market, the Autonomous Mobile Robots, AMR. AMR navigates via maps that is software constructed on the site or via preloaded facility drawings. To change its mission, the AMR only needs simple software adjustment. For example, there are three main types of layout design in AMR, which are single loop, tandem, and conventional layout. Next. Okay, first we will look into single loop layout design. In a single loop layout design, AMR travel in an unidirectional loop. When this system is used, the vehicle follow its constraint to travel only in one direction. As all the vehicles travel in the same loop, it requires less complexity in the control system. However, with this layout, the distance traveled by the vehicle might be greater when moving from one point to another point. Another disadvantage of this kind of layout is that a vehicle breakdown can destroy the whole system. Next. Next, we will look into the tandem layout design. The tandem layout overcomes some of the disadvantages presented by the single loop layout. This layout design decomposed into non-overlapping loops, which can contain one or more vehicles. Previous studies showed that the tandem loop with multiple vehicle TLMV layout has outperformed single loop and tandem with single vehicle layout in terms of mean flow time and vehicle utilization. The main advantage of TLMV is it is less susceptible to vehicle breakdown. Next. Third, we will look into the conventional layout design. In conventional layout design, mainly include unidirectional layout, bidirectional layout, and multi-lane hybrid layout. The main advantage of bidirectional layout is in the achievement of less vehicle travel time by reducing the travel distance due to the possibility of taking shortcuts and or using a smaller layout space. However, the complexity of the control system is very high. Next. Lastly, in conclusion, it is important that the next step for this project is the actual implementation. The automation of the material handling is a complex installation that comprises various processes such as inbound storage, batching, sorting, picking, and outbound processes. Therefore, it is important that the management support it as well as a cultural change to the production floor. The 5S concept are vital for the success of this project. The cells and axles need to be kept organized, allowing the flow of the mobile robots. The blockage of the axles can have major impact on the performance of AMRs, as the material will be handled by AMR and forklift. The forklift must be trained and be attentive to the AMR to avoid blockage or damages. As a manufacturing plant are not static places and pathway in them tend to collapse to the minimum allowed over time, this theoretical study presents potential limitation regarding the adequacy of for the real world operation. However, the discrete simulation tool can be easily edited to represent the reality over time. That's all from me. Thank you.